Mr. Dry, just to say before you start, I'm going to leave now, but thank you.
No, you're welcome. You're welcome, Mr. Moss. This is what we need to do if we need to get there. And I actually wanted you to see that how we are trying to incorporate the technology with the blended stuff. And I don't normally only have 4 people in my class. It normally is more.
Yeah, I was very disappointed.
You were disappointed. Yes, I can imagine. No, but we're trying to do this to bring back, because as of next year, as you might know, GSE have given us the concession ends at the end of this year for online.
Yeah.
And with the institution having said that all staff should be back on campus, I just started prior to that is bringing my lectures into the classroom space whereby I'm doing this and trying to just get, because as of next year we have been instructed to still try and have this blended approach where the student will still have access to what it is that should have lectured
Online, yeah.
in the online space. But we are fully back here. I started doing this it was more of a test run, but it works. And as you can see, I'm trying I'm trying to do that with what I have, with the tools that I have.
I love the tools, by the way. I really enjoy this.
And you can see where you can write. And what I do, I don't have, and the students can hear me say, I do not put the
Answers.
The answers on here, the dimensions. They have got the memorandum with it. They have it with it. It's uploaded onto MS Teams. So I go through and I follow and I scroll and I can write on here just to show. And it is one way of using the tool. So you have research money, you buy this I bought this out of my research money.
What's that?
But yeah,
Mr. Dry.
Thank you so much, Mr. Moss. I will speak to you later. I need to discuss some other aspects with you as well. But I've got a full day of meetings. I don't know whether I'll be
The full day anyway.
Yeah. Okay. Your other stuff, the people has informed you that your stuff is sorted out.
Yeah.
Okay. Thanks.
Bye-bye.
Okay, guys. Thank you so much, guys, and let us get back into this. On the board, you notice that I now have a different drawing, and it's a drawing that we're still busy with civil engineering works. We've now shifted our focus from the excavation, and we now will be looking at the concrete works. And I did mention to you the other day that when we look at the guidelines, we said there are certain aspects that we look at, particularly pertaining to when measuring formwork. And remember that with the builders once, we measured not exceeding 3.5 meters for formwork in columns, and exceeding 3.5, not exceeding 5. For the beams, we said not exceeding 1.5, those were the categories. But in civil engineering ones with the concrete work, we now indicate and we give the height of the formwork in the description. Remember, I said that when we started speaking about aspects that work for civil ones. I remember that. You can go back two or three lectures and you can go listen to the recording. I did speak to that. The guidelines, they gave the guidelines where you said that we give the height. For instance, if I had to look at this drawing, just looking at this drawing, and if we had to look at the formwork to the beams there, we would indicate and we would state that it is in the description. We would indicate and we would state that the height of the formwork of the beam is 50 meter 450, whatever. I'm just using that as not 3 meter 450, 4 meters, whatever. But no, it's not 4.1. That's different. That's not 4.1. You're a bit. See, that might be 4.1, but the height there would be different. The height would be more. The height would be 4350. But we indicate that in our description. Unlike in Boulder's Quants where we used to go, and in this instance we would have said exceeding 3.5 or exceeding 5 meters. In my description, but we now indicate that in the description what the actual height is of the propping up. Right? That's just one aspect that I'm looking at. We look at when looking at this drawing, and this is a reservoir. You all know what a reservoir is? And I know that the people there from almost at the northern areas of East London, they're from Buffalo, they've got plenty of reservoirs that are all the way around there in East London. So this is a reservoir, but you can see that the reservoir, looking at it from the top, you see 1, 2, 3, 4 columns. So looking at this is all open. Right? And then the reservoir sits on top there. Look at the shape of the reservoir. You see that it is circular in shape. We have concrete walls there, concrete slab over, and we have openings in there for inspections and for cleaning and for doing the like. Right? We're looking at this particular drawing. There are other aspects that I'd like to show. Looking at this, we notice that it says the height from the top of the column base is 4 meter 100. Right? But I have a look at what it says. The reduced level is at 14. See there? The reduced level is at 14. I mean, now have a look at this. Have a look at the top of the base. It's at 14.25. So what does that tell me? That tells me that my base sits there and my reduced level is there. You all see that? It does not reflect when you have a look at the drawing at the bottom. It doesn't show that by looking at the levels, that is what is being reflected there. Can you see? This is not just me going through the drawing. Again, as I always do, you guys know that I always go through the drawing. I always look at what is there. Before I start measuring anything, I identify certain aspects. And if I had to give this to you in a test, most of you would not have noticed the difference in the level there. Right? So I inspect the drawing and I have a look and I notice that. Okay, that's the one thing. So, and I know that I need to be aware of that. Okay? I go through and I will look at my drawing further and I see, and now with that being said, what I've just mentioned, that the base sits higher than my reduced level, I go further and I see the following there. Says that my working space excavate 300 millimeters back. Right? Remember, I'm still reading. I'm not reading my drawing. I'm not measuring anything. So what does that mean to me? That means that over here, I would go back 300 millimeters. Right? I go back 300 millimeters. What does that mean? It means that for these bases of mine, I would excavate Just use. I'll excavate back for my working space. Right? Says 300 millimeters. What that further means, that means that for these bases, I would have formwork to the side of my bases. Can you see? Are you with me, guys, online? Do you hear what I'm saying with that? So in effect, if I show my red, that will be, because those that are indicated in red there would mean that I am now talking about my basis. You got that? I've not looked at anything yet. I'm not looking at dimensions, nothing. I'm identifying things that I see and things that I have picked up from the specification and by looking at the drawing. Right? Okay. That is the one thing. So it means that what I said there, my basis, I would measure formwork. Okay? Also notice I have blinding, 50 millimeter blinding under my 50 millimeter blinding under my basis. I also notice that the concrete strength has 15 MPa for concrete in the blinding. And then 20 MPa in the basis. Then 25 MPa in the columns, the walls, the beams, and the slabs. Different thing? 50 MPa in my blinding, 20 MPa in my basis, and for the remainder, everything else, 25 MPa. Concrete strength. A very important aspect to that, all the formwork to this reservoir is smooth bore. That's given to me. Smooth formwork. All the formwork. That is now, I'm not just looking at my base now. I'm not, because now I will now make my way further up. And I notice that the column sizes here are given to me at 300 by 600. See that on the drawing? There. 300 by 600. The column sizes. Right? Now look at my drawing, and as I have a look at my drawing, and I notice the following here. And now this might sound a little confusing. There. I see 250 by 300 B. See it? Right? Where does that refer? What's that refer to? It refers to okay? Can you see that? Now I'll take you back to boulder squats. In boulder squats, we would not have said 250 by 300 or 300 by 250 deep. We would have said in boulder squats, we would have said you have taken the slab thickness of 350 and you would have added the 250 and we would have had a beam size of 300 by 600 deep. Right? That's what we would have done. Even though it is the same thing, but it gets reflected differently when we do those several ones. So what we are saying is that that beam that is indicated in blue is that there, and then it runs in the opposite direction. There's the opposite direction with it being reflected as follows. Okay. It goes through there. You see what I've done? Maybe I should use, let me just get that on. Can you see what I've done? The light blue line goes all the way through, the darker blue line stops prior to. Why is that? Because we need to deduct that one section of 300 millimeters wide. That section over there. We need to deduct that 300 millimeters wide. Okay, that's the one. The next thing that I look at, I noticed that a 600 by 250 beam. Now remember that this drawing was designed and drawn by a civil engineer. And the civil engineers or structural engineers, they always indicate the depth first. So don't forget that. They always indicate the depth first. So what that means is that 600 is the depth. Right? Is the depth. Okay? That's correct. No, that is not right. I'm wrong. They normally show the depth, they normally show the depth first. But in this instance, if you have a look at the drawing and you understand and you interpret the drawing, you would notice that the 600 is actual fact shown to us there. Why do I say that? I can say that because of the column that is shown to us there. Column that's shown to us there. And I have the size of the column. Size of the column of 300 by 600. And you can see that the 600 shows that. So the beam that I'm talking about over there, that is the actual width of it. But that beam in actual fact is a 600 by 600 beam. Does it make sense? If I say that the beam is a 600 by 600. The beam that has run all the way around there. I say it's a 600 by 600. Online people, are you with me when I say that beam is a 600 by 600? No response. Come again?
No.
Then someone put a thumbs up. Okay, another thumbs up over there. Right. Can you guys see what I'm seeing? So the beam is 600 by 600. Do you not see? Okay. Just hold it right there. Hold it right there. Just for a. Just drawing an ordinary slab as how we would have it in building. I'll show the steel reinforcement. Okay, and I say that overall is 600, that is 600, I call that 250, and I call that 350. Oh, you understand what I'm saying? Remember, this beam here is not standalone. not be strong enough if it has to be 250 millimeters thick because of the load under its own load around the circumference there, it would collapse. So the reinforcement would go there would be main steel there, and it would do that. That no problem to do that, whatever the steel, whatever it would be reflected in. So, in actual fact, you agree with me now that that beam is actually 600 by 600, because it's a 350 plus the 250 gives me the 600. Okay. And you can also see that that beam runs along the perimeter. And then on top of that beam, and that beam, if I have this, is that there. Or if you prefer, there. Ease of measuring, we use it over there. And then I notice that I have a concrete wall. The wall all the way on the outer side. There's my wall. Right? And the wall I can see there. So I've got my wall, and then I have my two slabs. One at the top, one at the bottom. So if I start and I need to measure this, I'll start off from, but now just looking at that, I have now identified the respective components that goes in. And I haven't measured anything yet. I've not measured one section of this. But I should now have a clearer understanding of what this drawing entails. Does that make sense to you guys? Right? Now, in the memorandum that I've uploaded, there also is a measuring list given to you for you that whereby you can look at the measuring list as to how we would go about the measuring thereof. Did the phone ring again? We now have a measuring list. So look at the measuring list. We're saying that we will excavate in earth for the basis. Extra over. But we may remember what we say about excavation. In building, we would measure risk of collapse to the sides of my excavation. In so what do we say? It is given to be included in the description. The risk of collapse. It's included in the description. Are you not in the And you're not in the Because earlier on you looked at me and you frowned in this slide. Okay. So, extra over for limited overall, and then extra over for long overall. And the long overall, you'll be told how far, as I said, that should be transported. And we do our mass concrete in our blinding, our reinforced concrete in our bases, and then we measure working space. Working space is measured. How do we measure working space? What unit of measurement? In builders work, we measure in meters squared. Measure working space in meters squared. But here, because we have the dimensions of what it is that we need to measure, we will measure working space in meters cubed. You see how you need to differentiate and stay focused on what it is that we need to do. Then we have our smooth formwork, the size of the bases. You can remember I drew that red line around the bases, so there's formwork. Excavating earth for working space, including backfilling and compaction. 25 MPa reinforced concrete in columns. They do but in beams, they do but in slabs, they do but in walls. Then we have the smooth formwork to sides of columns. We serve vertical surfaces of beams. Now here's the difference. When we measured in building work, we said smooth formwork to sides and soffits of beams, including propping up, not exceeding 3.5, not exceeding 5 meters high from bearing level. But in some ones, we measure particularly to concrete work, we say we measure smooth formwork to vertical surfaces of beams. Right? And that about to horizontal surfaces of beams. And we indicate how high it would be measured, not in a category. Smooth formwork to vertical surfaces of beams, circular on plan, to radius. Then we include the propping up, the height of the propping up. And then smooth formwork to horizontal surfaces of beams, circular on plan, including propping up. Then smooth formwork to the vertical surfaces of walls, circular on plan, to a radius that we will supply. And smooth formwork to soffit of slab, including propping up, also give the height. And then to the walls, a smooth formwork to the soffit of the slab, including propping, and smooth formwork in narrowers, that is for the opening, and then provisional sum for reinforcement. This is a measuring list of all the items. And in measuring this, you basically transfer the measuring list straight to your description. So we start measuring this, we look and we say the following in concrete reservoir on column. Excavate in earth for bases. This is provisional. Measured meters cube. And extra over excavation for limited overall or provisional. And extra over excavation for long overall, and the cubic meters multiplied by the distance of 20 kilometers, which we are being told, it's under specification, it says cart to weigh excavated material 20 kilometers. Now if I look at my excavation depth, this is where it is. Taking note of what I had mentioned of the different levels, the top of the base and reduced level. If you take note of that, you will now see where we come in with and why we can say that why we can say that the height is different. Because if I go in and I say 14.25, what is that? For my base, and I have that is, so that's 0.25. Okay? It means that if that is 0.25, and with my base size is being, where has my base size is? My base size being 1500 by 1500, and I should have, the thickness is shown to me as the thickness is shown to me as 400 feet. I'll just show that. The thickness is given to me as 400 feet. And those are the sizes of my bases, 1500 by 1500 by 410. But a very important calculation that we've done was the difference between those two. So if that is the case, it now means that I take my 400. What do I do with that 400? I deduct my 250. I add my 50, which is my blinding. And that then gives me my excavated depth of 200 millimeters. Do you all see that? You see that or not? You see that? Guys, please, in class, can you see the 200, that my excavation depth is 200? Online, can you see it's 200? I've got one saying yes. Only one person can see it online. Got another one. Right? I've got. So I need to understand, I need to know that we are there, that we can see the difference in. So meaning that we would only excavate that much. Okay? Right. So that is, so meaning that my dimensions would be times 4, my base excavation. Can someone tell me, if I had to give this straight up in a test, who would have gone and it was said that my excavation depth is 0.45? And be honest with yourself. Philip? Would you have written that? You probably would have written that. Anyone else there? I've someone in class that is honest and said, I probably would have done that. Who else would have done that? Okay, we are not scared to say, admit that we'd have made mistakes, such as that. No.
X.
Yeah, I've got a question here. Someone would have asked me whether there's a mistake with the levels. But it is human nature to make a mistake like that because our bases generally sit below the ground. They will not sit above the ground. So there's nothing wrong with it. But that is why it is so important for me to go through my drawing without starting to look at anything else, but to see what are aspects that might be problematic and what are those aspects that might be construed as a curved form. That's what I would do. But just to show how easily one can get yourself in trouble with this. Remember, we also don't measure keeping excavation free from water because it is deemed to be included in that description as together with our risk of collapse. So now my mass concrete, 15 MPa mass concrete in my blinding, also being measured provisional. Dimension is 1.5 by 1.5 by 0.05, and I have 4 bases with blinding of 50 millimeter below. My 20 MPa reinforced concrete in bases times 1.5 by 1.5 by 0.4. Now I use, because that is dimension. That's a net dimension. I do not have to excavate for that. I've already excavated, gone down 200 millimeters in my excavation. We then do the formwork with that as I had shown. And the formwork will be my smooth formwork to the sides of my bases, all still provisional. That is my smooth formwork. there. There. A smooth formwork around there. And it's 1.5, 5.4. We excavated 0.2. We excavated for the base, we went down 150 for the base and 50 millimeter for the blind lead. I'm not putting any formwork next to the blind lead. Okay? So my formwork depth is only 150 below the ground, but it is in actual fact, going 400 because we will now see that we will now have our working space excavated. So we excavate back in earth for working space, including backfilling and compaction, as I said. So when we do that, our excavation that will be mine. That'll be my working space. Excavation. Working space will be there. And the dimension that we are going to say, if we are not given the dimensions for the working space, we measure it in meters squared. But we were told that that we need to excavate back for 300 millimeters. So my dimension, therefore, would then be 1.5. What is that? 1.5. It's the size of my base. 0.15. And where does the 0.15 come from? You tell those third years, you don't talk to them now. It is from that is a section that is below the ground. Below the ground. That's the only section where I would now have my working space, and that would be that. The working space is there. And we have my dimension of 300 millimeters on the other side. Okay? So it is that is times that's 4 times 4. All okay? Remember, we are doing one side at a time. Okay? And remember, when we measured and under normal circumstances, if we have a structure and we then have working space, we normally indicate what that distance is. But we measure the working space, then multiply by, and we indicate what that distance is away from the structure. Remember? If you think back to third year, the working space, it was the length multiplied by the height, and we had the category not exceeding 1.5, exceeding 1.5, not exceeding 3 meters. And we indicate that the distance is, or would say it is flush with the outer face of the structure. So what are we doing here now? All we are doing here, we are now adding that as part of my dimension. But if that 300 was not given, we would have measured it meter squared. Okay? But because the 300 is given, we measured it meter squared. Right. Now I've not done that. I've measured my base. I've measured the blinding, measured the formwork, measured working space. I will now make my way to the top of the column, and measuring the columns, I still measure the columns to the underside of my beam. And the height of the columns are given to me as 4 meter 100. So it makes it easy for me to determine the size. So the concrete, we would have my concrete 25 MPa, 25 MPa, reinforced concrete in columns. And my dimensions should be 0.3 by 0.6 by 4.1 by 4. You got me? Are you with me? All with me? Right? So it's 0.3 by 0.6 by 4.1. All dimensions, I have not had to calculate anything because I'm going to the underside of my beam. It ends up my beam. And then as we go, and I now need to look at the concrete to my beams. Right. The concrete to my beams, I see that I've gone through in the drawing where I've made my notes as to what it is that I see. Made my notes that the beam size is 250, 300 by 250 by 300. Made my notes that the beams run crisscross through the center, runs between my columns. Made a note that made a note that my formwork is smooth. So I now say 25 MPa reinforced concrete in beams. See the difference between the description here and what we had in Boulder's work. In Boulder's work, it says that the different components will be kept together and that we indicate that would have been reinforced concrete 25 MPa 19 millimeter stone in slabs, beams, and inverted beams, underlining beams. That's what we would have done. But here, we do not. We just say it's concrete to beams, reinforced concrete to beams with a strength of 25 MPa to beams. And my dimensions now, I'm going to determine. I notice first and foremost, my diameter is 8 meter 100. You see the 8 meter 100? But my external diameter 8 meter 100. Okay? And I need to determine the beams, and when determining the beam size, I then look at and I go through and I use the section to determine that. Now, having gone through the drawing, I can say that my COP. What does that mean? Yes. Yeah. So that is my beam circular plan. Right? And that's the beam circular plan You guys said to me, that's it. Okay? So if that is the case, it means that this speed that I'm not talking about, run there, or I can show it. There, that runs there. Okay? Got that. So I'm not saying I measure my reinforced concrete in my B. I need to measure it. So if I know that my diameter is 8 meter 100, I therefore will need to deduct so my overall length from there is 9. Got it? Got that? It is equal to 900. So my reinforced concrete in my beam will therefore be 6.9 by 0.3 by 0.25. You with me? You with me? And that takes care of that. Okay, I know that that's 6.9. Now to go further and I say 6,900. That we have 6.6, 0.3, 0.25. That is that. And then, because over there, that 300 that I've circled there is the deduction of that section there where the two beams cross. Okay? Now, everything that I've written here, I can justify and I can show where I get those dimensions from. Now, I want to look at this section. That is circular on plan. And I know that if my radius, or my diameter is 8/100, and that external being circular on plane, and I know that the formula for the circumference of a circle is 2 pi radius. But I have diameter of 8/100. So what do I do? Divided by 1. You get the radius. Or I have my formula pi d. Right? But now if I look at that and I say pi d, I will be over measuring. Because I need to find that spot there. You find that spot there, which is the center line of that circular beam. You understand? So it means that I need to now say that it is 8 meter 100. What do I subtract from 8 meter 100 the diameter? Because I need to be there. What do I use? I can now say 8 100 and I subtract 2 times half times 600. Is that correct? So I deduct 600 and that leaves me with 7,500. 7,500 diameter or 3750 radius. Okay. Where do I want to be? I want to be in the center where you see that red line, right? I want to be, you see that red line. So meaning I want to be from there to there, to there. Right? Okay? So what do I say? If what I mentioned from here to there was 8 100, I now need to get to the center of the 600. What is the size of that be? So I must take off 300 there. Let's take off 300 there. Right? In order to determine the radius. So what does that mean? I'm saying deduct 2 times half times 600. I've got my 600 this side, I've got my 600 that side. So to take off 2, so I need to take off 600, meaning that my diameter then becomes from there to there, becomes 7,500. Or, if you want to work from there, becomes 3,750. Okay? So now 3,750, it is whichever one you want to use, either 3.75 multiplied by what? By which width? 0.6 and multiplied by the height of 0.25 or 7, what will it be? 7.5 multiply 0.6. Okay, that is times 5 times 2. Right. Get the pound sign, come now. So those two are the same. Okay? And that one, and this would be for a circular on plane. Can you see that these two are the same? Right? Are there questions? Or is it information overload? You with me? And you see what I've done? All I've done here with that and with that is that the one is we're using the radius, and the other one I'm using the diameter. Because of the formulas that we have there. That is why, guys, I go and I look at what does the formula say, and I don't look beyond just what is here. So I can be able to identify. Some people prefer to work with diameter, others, because we study pallet stuff. If sir does it diameter, I'm going to work diameter only. If someone else does it radius, I'm going to work there. So now I'm giving you the option that you can use either or. But check the two to determine whether you do arrive at the same answer. Okay. I think I'm going to call it halt here, and then I can continue with it, and I'm going to finish off next week, so that we can finalize and see what is where and where we are and who we are and where we are in the space. I can say this to you that I have requested exams to have our quants paper written on the first Friday of the exam. So it will in all probability be one of the first papers to be written. I've requested for it to be in the first paper, and next week we will be looking at various aspects and there's something that you guys like to talk about. What do you guys like to talk about? Before test or an exam, what's it? 5-letter word? Starts with an S. 5-letter word that you guys like to talk about that starts with an S. Huh? So, and before anyone asks me, I owe you guys plenty. The marks will be on the system. You can see Mr. Moss is here. We're going to finalize, and I will let you guys have questions, papers, but the tests all lying at home. Not the latest one, we're busy with the latest one. So yeah. So that is where we stand. Before anybody asks me, because I know what we are thinking at the moment.